perfect.
I'll stop by you.
Thank you. Thank you. Okay. What time is it? Okay, so I'm gonna go ahead and get started. Okay. 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 Hey, I'll just go ahead and get started. Huh? Oh no. So yeah, that's a whole nother system, and we're 5 minutes behind. But hopefully, this runs a little okay. So let's see. Okay, so this is going to be a workshop about multiplayer and co-location in AR. It's done for Magic Leap. That's what I'll use as an example, but it'll be able to be done across all platforms. So if you ever think, and recently there's been a lot of talk about the metaverse, right? And the metaverse won't be a thing unless we can share experiences with one another, right? And ideally across other platforms. So how can we adopt this digital universe, and how do we do this co-location experience where I can do something on one side of the room and you'll be able to see it, and how do I include it into my application, and also how do I make it cross-platform? So my name is Adrian Babolinski. I'm a senior engineer or applications engineer on the health team at Magic Leap. I've worked on interactive playgrounds, created the Magic Leap setup tool, and worked on a bunch of other AR projects and extended some SDKs as well. And today I'll be teaching you how to add this co-location experience into your project. So let's go to understanding co-location, right? So the idea, so how do we kind of set up a project, or how do we architect a project that we can then use with other devices without having to restructure our application? And in order to do that, let's go look at let's think of an origin, right? So if you ever use an AR device, you'll have, your origin will be typically where the headset is turned on if you're using an AR headset. And if you're using a mobile AR device, wherever the AR application is initialized. So here we have the world origin. So think of it as a room. And then we have, the room center, and then all the other devices that were booted up. And those are their origins, right? So now how can we bring those origins together in the center of the room? Well, we really can't do that. But how can we communicate that where we are to other players or other users? So here, we're going to look at a museum. So let's say Scott and Sue are at this museum, and they have a pamphlet of all the wonderful works of art in the museum. And how can Sue find Scott? Well, Scott can say, oh, well, I'm 4 units away from the Mona Lisa and 25 units away from the Night's Watch. And you can think of these pieces of art as reference points so that we both know where they are in world space. And you can, this kind of is like Azure World Anchors or shared PCFs or persistent coordinate frames on Magic Leap, where we can then use multiple anchors. And let's say we don't know, or Sue doesn't know where the Mona Lisa is, or they know where the Night Watch is. So kind of going through that, they'll be like, okay, well, I'm not familiar with this side of the museum, but I know where the Night Watch is, and I'll be able to locate you, right? And the Magic Leap has persistent coordinate frames in the shared world, but that's not very world oriented, or not very cross-platform. Not every platform supports it, and so it's not very expandable. So how can we make sure that if we have a device like the HoloLens that we also want to add to our world, how do we do that? Well, let's take a look at an empty museum with only the Mona Lisa. And we both know where the Mona Lisa is. How can Scott or Sue find Scott at this point, right? And so here, Scott's really close to the Mona Lisa, but also Sue knows where in reference on a coordinate plane they are relative to the Mona Lisa. And so Scott can say, or Sue can say to Scott, I'm 20 units away from the Mona Lisa, and then 18 units to the right or up. And so if you think of this Mona Lisa thing, it's kind of like image targets, right? So we're going to be using an image target to kind of create this colocation. And so what does this code look like? And how does that relate to our Unity project? Well, we're going to assume that you've already set up the Unity for Magic Leap. I won't go over the Photon networking, but if you do have questions during the hackathon, let me know, and I'll have with all your networking questions. Let me mute myself. And then you can go ahead with the question.
Will this work with any networking solution?
Yes. So yeah, you can. Most of it is it's easily integratable. We actually also have a version that's like very bare bones. But Photon is, since it is the leading networking solution on in Unity, and MRTK supports it. There's a tutorial on how to network objects. We just found it easier to provide this for the participants. And again, I'm not going to go over the image tracking. We have our foundation support. So we can kind of go over a high level overview of that. But that's a whole nother tutorial. And at the end of like these PowerPoints, all of this will be shared, and also reference links to learning Photon, to learning how to set up your Magic Leap, to image targets for AR foundations, and for the Magic Leap as well. So let's go to Unity and open up this project. And we're loading. I think in code, is everyone here familiar with Unity? Or somewhat? No? Okay, well, we'll kind of go over some basic math ideas to kind of go over how this colocation happens. Because it really is, if you think of it as objects telling the other users where they are, it's a little easier that way. But we'll kind of go over the whole setup. So I'm going to open up the main Magic Leap scene. Yeah, okay. Perfect. Okay, so here we have in the main scene, we're going to have the, like just a cube, just to see, make sure that we can see where the cube is relative to my original origin. Then we have the Magic Leap image target manager. So in the Magic Leap, you can have multiple image targets. So that's what we're using the script for. And then we have the colocation image target, and that grabs an image of this image target and says, hey, if you find this image, we're going to use that as the world reference point. And kind of go from there. We also need to make sure that we add the correct size. So like the world size, longest, the dimension in the scene. So we'll find the object, but you might have a different transform, so to speak, with scaling. That's okay. And if you are using a custom image target on the Magic Leap, you have to make sure you enable read write. and that you disable mipmaps and like nearest power of 2. And that way, the scale of the image in Unity is the same image that you print out. So with that, all that set up, we're able to do some image tracking. And then we have the network manager. I'll go into the scripts as well after just kind of an overview of the objects. The network manager is going to be the thing connecting you to the server. And if you don't have a Photon account set up, you'll need to do that and set that up as well. It's free for most use cases. And then we have the camera rig. So we just have a main camera and that's it. Yeah, so with that, let's take a look. So let's go into the network manager and show what's going on there. And Photon has a lot of tutorials about how to create a room, how to do matchmaking, and so on and so forth, but I'll kind of just go over the basics here. We have 2 prefabs that we want to spawn. We want to spawn the controller or the visual representation of the controller and a visual representation of the player, or for this use case will be just the Magic Leap headset. And then we can cache it so that we can use it later on. And we also want to track the players. Some of these things aren't used in this, but it kind of gives a better idea of what's going on or what's happening in the application. So on start, we want to add the prefabs so that we can spawn them into the scene without them being located in our resources folder, again, on the Photon tutorial. But then we want to basically start the network connection. When we start the network connection, we can then create or join a room, which also is here. Here we just create a random user ID, set some parameters for a room, join. Once we join the room, we create the player. Here we instantiate an object. You'll see Photon instantiate. And I won't really get into the specifics, but it'll manage the object on the network, so I don't have to create it by hand. I can instantiate it in one place and it'll appear in both places. If I log off, it'll get destroyed as well. And then just for an example, if I want to check if a device was running on an Android device, I can set a property here. And also the custom property. So that's really it for this part. Yeah, it's not really a huge network script, and there's a lot better tutorials than me just kind of giving this overview. But any questions so far about Photon? Yes. No, so Magic Leap doesn't use the image target from AR Foundations. So that's why you'll see in the project that we have our scene here and we have like an Android. So like the Android scene uses AR Foundations and uses an image target here. And all this will be shared, of course, but you can have a different scene for everything, or you can make it a little bit more modular. Any other questions? Oh, yeah. No, you just need the Magic Leap SDK. Questions? So let's go to the kind of overall part, what happens with the objects. So how does the object communicate relativity to a reference point? We have, I'll go to the Magic Leap one. So here, for example, if I open up the script or the prefabs, so when we join, we create this player head. I'll open that up. And will this minimize it? It will. Cool. So here we have a photon view, and that just associates an object between the network. A photon view with the ID of 0 will send information to a photon ID of 0 on the network. And that's set automatically if you're instantiating, so you don't have to do anything about that. Then we have a script called head post follow. And using that photon ID, I can say, did I create this object or did the server create the object? And here we say, if I own the object, I want this object to fly around with my camera. If I don't own the object, I don't want to manipulate the position. And then we also have the colocation transform sync, and this is what we're using to have the headset in the same location at the same time. Here we have a reference to that reference point. So we're finding a transform that we called reference point here. And we say, hey, find this object. Once we find it, and here where we have on photon serialized view, this is kind of photon template code. Basically, if we're writing to it, we own it. And if we're reading to it, we don't own it. So the reason why we're not tracking the camera if I don't own the object is because I'm reading it here. Here we do some math that allows us to get the relative position next with another transform. So for those familiar with Unity, it's basically parenting the object. And that way, with that parent, we're sending them the local position to that parent. And if just so that we're not forced to reparent things, we're doing the math here. And that way we can send that over relative to an object. And if we are reading, so here's also the rotation. And then if we're reading from it, we're just going to read it in update here. And we grab our reference point again, and we do the same thing relative to the reference point where I think I have it. And so that's why, since we're just sending the local position, it's the local position to the reference point. So if it's 3 units away from the picture, no matter where the picture is, if it's 3 units away, it's 3 units away, both ways. Any question? Okay, cool. So with that, we also do this for the controller, and you could really put this on any object and it would track relative to any reference point. So if you want to use persistent coordinate frames, you can use a persistent coordinate frame as long as you assign a transform here and say, here is the world object that we all agree on is here. So of course, if you move the object or move the image anchor, it won't be synced. And yeah, so there's kind of that. Okay, you want to see a demo? Okay. Originally, I thought I had 2 hours for this, and then this morning I was told only 1 hour. So instead of building to my device and removing like 15 slides, I have some videos that I'll show you that will be better than me fumbling around with an Android device and a headset. But here are just some like concepts or things that we've done in the past with this code. So for example, if you have 3 magic leaps, you can have 2 interacting and 1 recording, right? So that kind of beats the trying to sync multiple devices. And it could also be a phone or whatever. So as you see, it's tracking our headsets, it's tracking our movements, and using MRTK for the transform, For the object manipulation, we're just syncing the positions of the objects. And controller and so on. Cool. And a little bit more advanced thing we could do is, instead of, for example, syncing a whole game, we could just sync a position of a phone and send a camera stream, right? So if you didn't want to do anything of your on networking, you just want to be able to say, here's a camera location, retrieve the camera frame, the depth camera frame for that image, and send it to my device. You can also create kind of a recording technique. So also just kind of a prototype project where the code will also be released. So here we're just connecting to the headset, and once we're both tracking the image target, we see 2 image targets lined up. All we're sending is the intrinsics of the camera. So the cameras line up in virtual world. And then we have, so here's my twin brother, and we can see his hand lined up and his controller, and can manipulate objects. And all we're doing is sending the camera image frame, and hence the lag because we're sending it over Wi-Fi, but also just something you can do with just like an image target. So any questions about setting up your project, or just like networking in general, or image tracking, image targets? Yes. Yeah, so great question. Here we have, for example, I'll just do this. So here we have ownership transfer fixed, which means once I create this object, no one can take it away from me. There's an option to say request, which means if I want to manipulate this object and I want someone else to see that object being manipulated, I need to say, hey, can I manipulate this object? And then you say yes or no. If yes, then the other person manipulates it. Takeover requires no request. So if I throw a ball and another person wants to catch it, no matter who created the ball, now they take ownership, and whatever they're doing to the object overrides the other person's. So it's the best way if you want to manipulate, for example, crayons or markers in a scene. That way you don't have to worry about ownership transfer. Yep.
Or all objects all the time setting their positions, or only objects being owned?
So all the time. So and you can optimize, but I think
Follow up, like, what does that cap at?
I think in general, the Photon does a really good job of syncing the transformation of an object. It optimizes the way that it transfers all the data over. So normally you could use like an RPC, which would be like a message or an event, and that would get really slow, right? Using a Photon stream, it doesn't have to replay. So like if I manipulate an object and I put it here, the next person that joins doesn't see the object here. It's already here without taking up any bandwidth on the server. So that's like typically if you like wanted to, like, I don't know, create a line on in every location. If you didn't use like a Photon View, or like if you used another networking solution, you might have that issue where you're like, you join and it's somewhere else, or things are already going off sync. So the syncing on Photon is actually fairly stable. It also syncs physics, which is also something most things don't, I don't think. Yep. Yeah, so any of that will be, so any object manipulation that you want to do, all of that will sync, because you're not sending in the input, you're just sending the object position relative to your input. So if I had a pointer, it would react the same way. I'm just saying that when I'm moving the object, it's not like here, but it's here. So all that's, and MRTK has a really good example of using networked object manipulation. Yep.
So you're saying physics was done in the server or?
No, so so Photon does an optimization for sending like rigid bodies or like collisions over through Photon magic. And so so that way when, you know, an object bounces off the wall, it doesn't, you know, depend on the physics engine to do the same thing in two places. So
Yeah.
at least that's, yeah.
So let's say we are playing ping pong between two people. So what's the bottleneck? Always like fast between bats. What's the speed?
Yeah, so I think it's fairly good. Like if you want to do ping pong, I would think, you know, maybe calculate the bounce, like predict, you can do like a trajectory. So that way you don't have to necessarily use the fixed update. Or like if you want to, I don't know, hit it with a racket. That's a good question. I'll have to get back to you on like if there is a ping pong demo, because I know that if you're transferring the ownership in physics, like when you hit it, I don't know if it calculates like, you know, the data that was already going. So, but there is a Photon physics demo, so we could probably do on the desktop. I like really ran through this these slides, so I'll upload the longer one and also the builds. So when you get your devices, you'll also be able to try it out with using two phones or whatever. So you're not necessarily limited to needing to use an AR headset. But yeah, that's like, I think typically for all AR experiences, ideally all of them are networked, right? Like it would be a very lonely world if you had just the, oh, well, I can't see what you're saying. Especially, for example, the Magic Leap's camera you saw in the first video, it's fairly bad resolution. And so it doesn't give you like a great idea of, oh, this is what I'm seeing, or, you know, it's like watching someone do VR, you don't know in which direction. And so, for example, there's like in the newest Oculus update, you can, if you have an AR or like a iPhone, you're able to kind of do a body masking of the AR experience, right? And so it's like, how do they find their reference point, since like the Oculus doesn't like scan an image? And what they do is like they basically bump each other. So you say like, oh, your head's here, my head's here. And so now we know each other's locations, and from that we move on. So that's how in VR they would do it, or that's how VR syncing happens if you're using a phone and a VR device. So yeah, sorry that like, yeah, I definitely like, yeah, trailblazer. This, and also another package that will also support other localization options will also be there. So if, for example, PCFs or persistent coordinate frames for the Magic Leap, you don't have to scan it in. As long as you're like scanned in the same environment, or it like understands that you're in the same space, it'll compare those points automatically. So you share those points and you don't have to necessarily look at an image, or like I could be, for example, start my device there and I would already be localized, which kind of takes away from the, now I have to go here and, you know, scan the image as well. So that code will also be released, and then that can be added to any other anchor scenario. Any other questions? Yep. So yeah, so the Quest, I haven't done AR with the Magic Leap or with the Quest, but if you want to sync like the objects, as long as you have a reference point that you can make sure is stable. So for example, like mobile AR tends to drift. So what you'd have is, if you only have like one image target, if I'm moving my device, there'll be a moment where that image target's like across the room, but I won't notice until I look back at like a user and then, they're like here or whatever. And then the only way to relocalize would be to go back to that image target. If tracking gets lost, if you use AR foundations, or it'll try to regain, but you'll still have maybe a little bit of an offset. And so if it really matters that you have things together, then I would suggest adding more image targets, and that way the chances of relocalizing are better.
I just keep late, but it was so Photon has its own SDK, and this is something like the GitHub for the hackathon.
So yeah, so there'll be a link. You just have to set up an account. Once you set up an account, you'll basically, so here I'll hopefully let's see. If I go here, somewhere here, there's a Photon point. Here, Photon Networking, and it's called the Pun Wizard, and you can go all the way through it. And there are other, I guess this will be the notes, but you want to use Photon Pun. It's like the thing that now that you're like using something else, and like there's Turbo and whatever. I don't know any SDK off the bat that supports that like an object manipulation fashion. So I would use Pun 2. And once you import that, you can like locate the server settings here. You can change the logging, the RPCs. Here's the settings. So here's my app ID. And when you install it through the Unity asset store, the window will appear and say, hey, configure me. And then any application. So in order to like, if I built the same application with a different Pun ID, we wouldn't communicate. So I don't know if you really want to use local like peer-to-peer, this probably wouldn't be the best option. Photon combines both peer-to-peer, where I can send a message to another user without having to send it directly to the server and then back. But it also prevents, if I want to say like, I don't want a network connection at all. Like if I am using Wi-Fi direct, for example, you wouldn't be able to use Photon. That's the limitation there. But I think for the most part, yep.
Yeah. Hi, Adrian. This is Karthik joining from online. So I have one question. So is there a possibility that we can do the referencing using the anchors on surface tracking, or is it not possible? We have to only do it with the image targets?
Sorry, can you repeat what, like when you're referencing using what? Sorry?
Referencing using, so if we plan to use surface tracking, so and then anchor can be used for referencing between the two sessions or between the two users. So if one user augments an anchor, that will be used as the reference, and when another user will augment an anchor, that will be taken as the reference for the second user.
Yeah, so that's another option, is as long as the reference is in the same place for both users. So like if I want to skip all this image stuff and I want to say like, I only have one table, or I want to put a 3D marker on the ground with, facing a coordinate, or like, touch the ground at where the tape is, you could use all of that as a reference anchor.
Yeah, okay, thanks.
Cool. So I'll just, okay. Yeah, so there's that. If you are planning to do any co-location, I'll be on Discord when the links appear for everything. My Discord will be in this, as well as all the other networking questions and Unity questions. So I'll be happy to help anyone get set up with the Photon, as well as to like network their application if they want to use co-location, or if they want to just use like colocation just for a recording.
Aren't all the teams in the same building this year?
I think, yeah.
Hopefully they come to us if we're like really stuck.
Oh, well, so we have quite a bit of people from Magic Leap here. So, so yeah, we have quite a bit of support. So at least you won't be necessarily, yeah, like it won't be like, it's not just like me and my twin brother. It's like, and developer relations at Magic Leap will also answer questions. So we're committed to the cause and we're happy to help. So yeah, if you have like, as long as you're not like, oh, I'm going to use like, create my own server and whatever, I'll be like, can't help you with that. But if you're using Photon, then it'll be good to go.
Hi, Andrew. This is Saurav here from India. I'm joining from online. I have one question. Like, is there any one reason using Photon over the netcode? Like, the netcode is also networking plugin by the Unity.
So mainly because it's supported by MRTK. So
Mhm.
MRTK will allow you to use like a HoloLens and Magic Leap, and it says AR Core. So I'm assuming it will. I don't know what that looks like, but at least you'll have the
Yeah,
object
that's netcode supports AR code and AR conditions.
Yeah, so it's just mainly for the object manipulations and how that
Mhm.
works through MRTK. But you could use any other networking part. The main thing is making sure that if you're set like, and you could like sending the reference point is probably the easiest part in a custom networking solution. It's typically making sure that you transferring authority or making sure that you're not you're sending things in an optimized way.
Thank you.
Cool. Well, thank you for attending. Yeah, again, if you need anything, reach out. I think we'll have our own channel on Slack if we don't, or on Discord if we don't have it already. But we'll be always reachable there. So I think like everyone's planning to stay like, day and night. So we'll be happy to help.
Question about sort of like persistent AR between sessions.
Mhm.
So suppose if I want to scan a particular area, and like suppose if I want to augment something specifically to the side of like this table, once I've scanned this table,
Mhm.
like created a mesh of it, how do I go about doing that?
So in Magic Leap, we have persistent coordinate frames. So if you want to have when you scan, you'll probably have an anchor, and you can say, hey, it's near this, and the next time you scan into the same area, it will say, no, there's an object here. And so so like, for example, one of the things we do when we're like creating like this augmented world is saying, there's a poster here and we don't want to necessarily set up all the AR objects. So that will work, and you can just save it. And that's fairly, I think, yeah, the position's saved through, we have in our SDK. So it's actually really easy to do.
The other question I had was, so I'm a grad student. I'm planning to use Magic Leap for a study that I'm running, comparing like monocular and binocular like head-worn displays. So I wanted to know, is there a way that I can just disable one of the Magic Leap eyes?
Yeah, so if you disable the camera typically on Unity renders to both eyes. If you disable